Hi, this is Gunas again, Assistant Professor for Mechanical Engineering at SNS institution. Now we are seeing about design thinking based on the tool path generation and simulation digital manufacturing. Okay, now we are seeing introduction.
So, when we see about introduction in mechanical product manufacturing, tool path generation is a critical stage where the mechanical tool movement is defined to shape a compound as per design. Traditionally, tool paths were generated manually, which was time consuming and prone to errors. With the rise of CAD and CAM, digital manufacturing system, tool paths are now automatically generated and simulated before actual manufacturing. These case studies applies design thinking to improve tool path generation and simulation for a complex aerospace turbine blade used in jet engines.
Okay, good.
Next, we look upon it to empathize. The goal here is to deeply understand the pains and the needs, challenges faced by the stakeholders, such as the engineers, machinists, and quality inspectors. Mainly, the users are CNC operators, manufacturing engineers, aerospace design teams. And the pains mostly created by them are manual tool path creation, which is very time lagging, and the collisions between the tool and the workpiece during machining. This causes the tool to get damaged, and high scrap due to the wrong cutting parameters and lack of real-time visualization. So the users are usually need automated and optimized tool path generation, simulate before actual machining, and also reduce the cycle time and the tool wear. And they also in need of integration of PLM with the CAD. So the output of this empathy stage is to that the operators need a reliable tool path generation and a simulation system that reduces machining errors and saves times and ensures safety in manufacturing critical aerospace parts.
Okay. Okay, third one, define.
So let me explain the problem statement of this case study. Aerospace manufacturers require a precise and automated tool path for the generation and the simulation solution to the machine turbine blades efficiently to minimize the errors and reducing the tool wear and ensuring the safety before the production. This defines the direction for the ideation and ensures the solution focuses on both the technical accuracy and the user experience.
Okay, good. Now we are going to see an ideation. AI assistance tool path generates a using algorithm that learns from the previous machine's operations to suggest the optimal tool paths. 3D simulation integration, real-time visualizations of machine to detect conditions. Cloud-based tool path sharing. Engineers and machines students across the plants can collaborate on the same simulation module. IoT feedback loop. CNC machines feed live cutting data back into the PLM systems to improve future tool path generation. User-friendly interface, graphical displays which drag and drop the simulation to reduce operations learning curves.
Prototype. I'm going to explain about the prototype. The digital prototype is developed in the Siemens Xen CAM and team sensor PLM. Features of the prototype are a CAD module of the turbine blade embodied, and the CAM module automated generated multiple tool path options. Simulation engines visual mechanic without the tool and interaction. The parameters such as cutting speed, feed rate, and depth cut adjustable on real time. The prototype allow testing and feasibility before applying the actual.
So now we are going to see about testing. The prototype is tested with the real users like engineers and machineries. So users or CNC operator test different cutting strategies. So aerospace engineer validate tolerance and surface finish in simulation. So collision detection prevent tool crash, which reduce downtime. And automated path generation saves up to 30% of programming time. So real-time parameter adjusts improves flexibility. So feedbacks of testings are user request one more GUI and predictive tool wear analysis. So testing ensures the final solution not only works technically but also fit user expectations.
Going to be conclusion.
transformed into a user-friendly, efficient, and error-proof digital manufacturing solution. Empathy captured real operator struggles, defined, clarified the problem for aerospace manufacturing, ideate produced AI, cloud, and IoT-based ideas. The prototype created a working digital solution.
Okay, good. Thank you.